Okay, I've started recording, so let's get started. Hold on one second. Okay, let me share my screen, and you should be able to see my screen as well. Um, okay, so just to um, refresh your memory, what we did last week. On the Saturday stuff, right? We did quite a bit of um, data frame programming. Concepts on the programming, right? Things like we did ingested CSV file both in 1.6 and 2.2 both way, right? One CSV file, and we ingested Hive tables, and we worked with um, like ORC file formats. We worked with ORC and Parquet, ERQUET, Parquet. And we did few I think again we did few what you call data frame APIs like things like select, filter, group by, sorts, order by, those kind of stuff. So we did few some average, aggregate operator, those kind of stuff. And there are quite string like few concat and substring. Those we just looked at it. There are many more are there. we'll cover few more APIs today as well. There are some important ones which I want you to know. Apart from that, we also talked about how to do it, SQL, Spark SQL way. Right. So you went to also looked at how to do Spark SQL both ways, both API and Spark SQL, right? So of course, Spark SQL it's much easier. You just say SQL context dot SQL, and you fire up anything. You create a temporary table, you fire up, right? And it's much easier in Spark session that in 2.2. Once session is available, you can pretty much do everything like session.sql, right? It's whatever the name of a session, it could be Spark, it could be, right? Right away you start consuming data from Hive. It's very easy, and you can pretty much write everything, any query you want, right? And that becomes a data frame. So today, what I will do, I will just extend that. We'll talk about few more APIs. Actually, one of them is called with column. It's very important API or operator you'll be using a lot in your work. So just want to cover that with column. Join. So join and with column. Okay, so that's a couple of I'm just remembering those two important things, but there are many others, but those are very common. And we'll also look at how to ingest JSON, and we'll work at RDBMS file, how to deal with these source systems. In RDBMS, we'll talk about the MySQL, and JSON file, how to read JSON files. If you remember Hive table, we created Hive tables of JSON file. How to do the same thing in Spark. Okay, basically when you go to work, they'll say, hey, okay, we have JSON files coming in. Okay, you need to process it and feed it to EDW, Enterprise Data Warehouse. So these are very common use cases. So you go ahead and write your program. It's very common. JSON, XML I have not seen much, but JSON or files from the delimited file, or what you call Hive tables. These are the things you'll be dealing with at work. And and you create your business. You basically write transformation logic. That's your major work, 80% work. Writing those logics. That's where the API is. Knowing more API is better. Right? More you practice these APIs, you will get better and better. So, and depending on if it's Python or Scala, the deployment will be different. So the execution will be different. That we'll talk about on Saturday, or if you time permits, we'll talk about that a little bit today. The whole Spark submit thing. Okay, and so JSON files. I'll just briefly talk about XML. XML needs a what you call external library to be installed, which we don't have it. We can install it and practice it, but as I said, not very common in the industry because mostly it is JSON nowadays. People those who started XML many years back, a lot of external data files are typically JSON nowadays. With rare cases, people those who are working with old systems, old technologies, there are some are still XML files. Like Charles Shaw, when I was working a couple of years back, they had some XML files as well. So, okay, so those are things we'll talk about. If time permits, we'll do UDF, data from UDF. So that way, you will complete the kind of data frame specific concepts. Although data frame is the main area, there, many things can be done onto it. Doesn't never complete. So it doesn't what I call finish in terms of course content, but um, at least the concepts will be covered. Okay. So that being said, let me go to our this thing, and we'll start with few APIs. So let's start with few APIs with column and join. I just wanted to explain how that works. Okay, Spark Shell. I'm still doing it in Scala format, but doesn't matter. We are all doing everything data frame. There is no, it's completely, as you see, language independent, right? Okay. So I'm going in there. In the meantime, let me look at files, class, Spark, data. I will pick up a couple of files. I have kept the other files like the sales or that are for your lab work on Saturday. These three things we'll be using to create some stuff. I'll have these three I'll be using for lab on Saturday. So 1.5 hour or 1 hour you'll be doing just all the stuff that we are doing here. We'll try to do it in the class. Okay, that we'll have some good practice there. So we are inside Spark. Okay, I'll go ahead and what you call we'll look at what is it called API, right? So API. So let me do it the table way, because since the CSV format is not supported well within the 1.6, let's start reading data directly from the table. Okay, if I go to the table, what table we have created? We have few tables anyway, so let's go ahead and we know already. So SQL context, right? Context dot SQL. I can directly read data from the table, right? This is one way. Select star from the table name we have created earlier, Hadoop trg dot. If you remember, we have created few tables in our Hive session, right? Trg. Let's read the table. What you call store. Okay, we have a store table, if you remember. Okay, so let's read it. Anytime you read something, it creates a data frame. Why don't you assign it to a data frame called store data frame equal to this? So this is something you can directly do. Just it will directly read. Okay, there is some error, maybe the what is it complaining about? Reads feature cannot be used because of what is it called? Select. Okay. Oh yeah, good catch. So we're reading the table using SQL context.sql. In case of 2.2, right? In the case of 2.2, it will be Spark instead of SQL. That will also work. I'm not saying it won't work. Over there, it will be Spark session. That's the major difference. So here, I'm going ahead. In case of what you call 2.2, it will be Spark. Typically, Spark is the session. That's the default session to Spark 2.2. Whatever you name the session name. Here our SQL context. Here it's 1.6 because we are using Spark SQL context. Here you will be using Spark context or Spark session. Okay. Here you will use session. Here because session is not available in 1.6, we are using single context. So this is one way, and you already know that we can do it other way as well, right? From the read standpoint, how do I read it? I can also do read, right? I can do read, and what's the command? I think table, right? Is it table? I think table. You can just read the table directly like this. Let's see. So both way it works. So you can do this way or that. Here you have the option to select whichever column you want to. Suppose you want to select only few columns, or you want to put a where clause, all that. So that way you can trim the data, right? So that's also possible. So anyway, so store data frame, either let's look at it. Let's look at the schema. And we have store ID, store name, city, and state. So I want to talk about a couple of okay, so that we have. I want to show the join as well, right? Let me bring the other table. Okay, what's the other table? Let's bring the sales table. Sales table, and that will be sales. You can do the same way again. .sql or this way, both will work. Sales. So that you read sales file. Let's look at the schema of it. Print schema. It has product ID, store ID. Right? So now you can go ahead and read this. You can do a join, right? Just like I'll show the join here. In both the ways, right? You can do it in API ways, and you can do in what you call just logging into my other site, just to my I'm logging into my office work what do you call office laptop to see a syntax there. Okay, all right, okay. This ID, this how that. Okay, I want to do it two-way. Okay, so MVM date. Okay, all right. So now I want to combine these two tables or join these two tables. Okay, I want to see just join the two tables, just all the columns. That's okay. Let's go ahead and say val join but a frame. Okay, let's do it. Then I want to join these two tables based on what? Store ID, right? So what's the what? How do you join it? Straightforward. You can just sales.df dot join. Okay. You can do this way and mention the other data frame. What's the other data frame? Store data frame, right? So you are joining store data frame on something. This is where the columns will come into picture. What columns you are joining on? The new way of doing it, I'm hoping this is also supported, because I at work I am doing 2.1, 2.2. And here you mention the columns. It could be one column and two columns. So in our case, it's store ID. If the ID just so store ID is the column name that we are joining. Okay, since it is a column value, we'll put it in this way. It could be more than one column. Then you have comma, comma, comma. You can put more than one column. So that's the join on. Okay. Then you say how are they joining? They are joining inner join. Okay, inner join, and so illegal part of the sample expression. So I'm looking at the syntax of my work. If it is, why it's giving error. Issue. There is another way. I'm just trying to see if this works. Okay. Giant data frame. Oh, maybe it's not supported in 2.0, 2.1.6 maybe. Let's see. Giant data frame equal to this cells. Store df, store ID. Store ID. Okay. How? Where is it complaining? Store ID. Store ID. Okay. On close literal. I think it will matter, but let's see. Character literal. Maybe it's not supported in 1.6, this syntax. Okay, maybe it's not supported. Okay, we'll do the other way, which is store df dot store id equal to sales df dot store id. Default is inner. I don't have to mention that. Otherwise, you can mention the join type inner outer. Let me see. Store ID. Store ID. Store ID. Okay, store ID. Okay. Dot. These are sometimes the syntaxes. Okay, so that one works. Okay, so you have to mention this way, not it doesn't take this way. What we did earlier. So this data frame. So we are joining this data frame with other data frame, and this is the condition. Okay, this is the condition. Why three of them? I don't ask me. This is how the syntax is. So I'm saying it could be more than one. You can say and. You know, you can do. If there are more than one conditions, you can put this more one conditions. You know, over here, like and other conditions. Okay, if you have more than one columns that are joining, you can put and condition here. Okay, since we don't have it, we are not putting. This can be, so this is one way showing, but there are other syntaxes you will learn. One of the ways I've seen, for example, you can do store da. This works. Dollar. Anyway, I don't want to go into that. Okay. I think there is another way called dollar. This equal to dollar. I think I need to mention the, because this, yeah, that will also work. Oh no, it didn't work. Okay. Yeah, I'll get there. How, instead of how, you just put the inner or outer. Okay, let me go back to the original. So this, I'm looking at the syntax. Sometimes it's just tricky. So this is what I use, but there are other way. There is another way to do that. But here, another way in the sense, you know, there is a. I'm trying to see the syntax. Okay, but anyway. So here, inner is default. I don't have to say how inner. I don't know whether how works here. There's a little bit of between 1 and 6. Maybe this still works. No, it doesn't. So just say inner will work. Otherwise, the left outer, right outer. You can mention that. I think it said left. Is it just left? Yeah, left or right. Okay, that will left outer, right outer. Okay, so inner don't have to mention unless default is always inner, so you don't have to mention it. But if you have to mention, that's not a problem. You can always mention that inner. Okay, So that means a inner join between the two tables. So the join data frame should have all the columns from both. That means if I do print schema, you will have the columns from both the tables. Okay, product ID, store ID, transaction date, unit, this, and from both. Right. If I go ahead and join df dot show, it will give me uppercase case sensitive. Now it will show me columns from both the tables because it's a joined. It's already joined, so it will give me the output like this. Okay. And other than that, I can just to count how many did join, so we can see how many satisfied the inner join. It may not be. We had 1,000 in cells. Oh, all of them has a record. Yeah, I think they should have. Okay, all of them. But I could do left. So anyway, so you can do left and right. So what is your left? Left is your cells, right? Right is your store. If I do right, probably I will get more records. Let's count 1002. That means there are two stores which does not have any cells. So those two are coming in here. 1000 have one or there are, what is it? Okay, left outer. We say right outer, right? Right outer means give me everything from the store side, right? So how does it work? Right outer means give everything from the right side. Left outer means give me everything from the left side. So that means give everything stores. That means two stores didn't have any cell. That's why it is coming in here. Okay. I don't know whether left has anything, but you can do that too. What does that mean? Left means there are some cells which does not have a store. Yeah, that doesn't work. We don't have any such record where cells is there, but there is no corresponding store record for that, right? Every cells record have a store. That's why we didn't get anything on the left outer cell. But right outer, there are a couple of stores which have no cells. Okay, that's why it shows here. Okay. Anyway, so we'll go back to our inner join. Okay, inner join, and this is how we can join those two data frames. But it's very easy if you want to do in the SQL way. How do I do the SQL way? Instead of doing this, I can generate even not a SQL way. Let's see, join DF, right? I can directly pull it from the table, Hive table, right? If they are in tables, I can do it, what you call SQL context dot SQL. Just join the tables, select star from store or Hadoop trg dot store comma Hadoop trg dot cells, where just pure SQL way, right? I can do alias here so that it will be easier for me to write a b where a dot store id equal to b dot store id. Okay, so that also I can do. Okay, I didn't put the double quote in the beginning because it is between the now join here dot show, same thing what we see in the other way. Okay, so there are many ways. Just pick the one which is easier for you. I mean, again, API way you have to remember the syntax. That's the only thing, and it doesn't happen overnight. As you start doing it slowly, you will remember, right? This part I'm talking about. So there are various, and as you start working, you'll find a lot of you do Google search, and there are many syntaxes you'll find. Okay. You'll have many syntaxes, different syntaxes. The way you represent this column, there are various syntaxes. And just don't ask me why 3, but this typical text 3 for comparison. Okay. Okay. So inner, outer, and you can have inner, outer, all the options are there. The left and right. This is how you can do all three types of join. Maybe there is a full outer as well. I have not tried. You can also try the full outer as well. Not sure. If it takes it, then it should be there. Yeah, it's there. Full outer is also there. So that means full is there. Okay. So this is how you can join various ways. Directly table, you join the data, the tables, join the files in the table. From the table, that's easy if you are good with SQL, or if you are going to API way, just use the join statement. Okay, if somebody asks you, give me the syntax for join, API syntax, say join the join data frame, the output data frame equal to one data frame dot join second data frame, and give the condition, one or many conditions, and specify the type of join, inner or outer. That's your join. Okay, once it's a data frame, you again back to whatever you want to do. Right, I want to select few columns out of that. Right, I can say from join div, I want to select only store name and or select store name and the total, the sales units and dollars. Right, I need only these columns, not rest of the stuff. This is where you can use select and show. Again, I'm just showing it here, doesn't mean that you are show. You need to show, or maybe you want to create another data frame out of this. Okay, so just doing projection for only for 3 columns. So this is the data you need. So right, and you can create extract, and either want to create a file, how to save it to a file. You can do save, right, or write. You can know the write. You can the format, mode, all that stuff we studied last week, right? What format you want to store, you can write, right? That's your ORC, Parquet, CSV. All those formats are supported, except CSV not supported here. Mode, you have overwrite and all that, right? So you can just putting it here. Mode, you can specify. Then we say save. Then you give the path, right? That will save it to the file. So you created output and you want to save it somewhere. That you can do. Mode is overwrite or append, or format is Parquet, ORC, CSV, JSON, all that different stuff. Save with the location of the file. And that's how you select whatever you want. And maybe this is where I want to say aggregate it. Let's say total sales by store name. I want to say aggregate it. Do the aggregate. You have to group by first, right? Before you do any aggregation, you have to group by. Group by, let's see, store name. And then AGG aggregate. And that is the sum of what? Sum of units, right? And sum of sales, sales amount. Okay. One more. Dot show. Okay, where did you miss? Group by store name dot agg units. This is missing thing. Okay, so I want to see. Okay, give me the total sales by store, right? So that's what it's giving right now. The output. Okay, total store. Okay, this is null because I think because of there is nothing available for this store. I could even, how do I take out those cells which are not null? I want to show only the ones which have some cells, not the null ones. Maybe something we can do. I'll go ahead and do something filter, right? I can do filter here. Okay, show only the ones I need. Where for that I need to do alias, so that I can refer to that alias. Let us say this is, I'm putting alias for the sum, right? Say total units, UNIT units. Okay, let's put alias here so that it will be easier for us to refer here. And here you say total, right? That total units not equal to null, maybe. I don't know. I'm checking. This is where you need to just run through the syntax errors and all that. Total units, maybe it will be call. Okay, maybe you have to solve something like this. Okay, let me check the syntax. How to check null. Spark data frame. Check if column value is null. Is null. See, it's all easy in the other way, but here, okay, null like this. Okay. Filter equal to null. We are saying not equal to, right? Okay. When you use the works well for filter, this is not member string. Not equal to this. The problem seems to be operator precedence. Okay. Try to use braces. I don't like braces. Anyway, I'm just kidding. Filter not equal to this. Okay. Is not null. Oh, there is not null. That's also there, which is good. Okay, maybe we can try this as well. Hopefully, this should work. Is not null. First one says null like this. Is it? Let me try this syntax. Two of them. Is it one or two of them? Okay. Equal to or not equal to? Filter. Okay, filter out means filter. Nothing. This will work. Is not null is better. Why? I'll tell you. Okay. So the nulls are gone. Okay. Why it didn't take this one? It is looking for a string literal. So you know, if people coming from the database background, null is not a value. Null is a string literal here. It might work if I do this way. Maybe I take out this thing. If there is something called null, no, it still not doesn't work. Maybe case sensitive, I don't know. Okay, no, it's not there. Okay, so we have to go with the other option where is not null is better. So unless you have an actual value NULL, there is not a value called NULL. If I go back to our original one, right? So where is it? Right? Sorry. Here. Okay, so in the original, if you see the data, it had the value null. The null is actually not a value. This one, it's a there is the null means there is nothing there, but it's not a string literal, right? So if you have to make a comparison, this will not work like this. This one will not work where it's a null. We are looking for a string. Instead, if you do is not null, that's checking the value. Does it have anything? That's what you are looking for. So you just have to try out whatever. Nobody's expert in the sense you have to try out. So, and tons of documents on you can, when you do that, just search on it, you will have tons. You see, most of the thing I'm also searching and doing it. I don't even remember every syntax. If I remember, I'll forget again after a few days. So there is no way I'm going to remember all these things. So just have to know how, as long as you know how to do it, you can do it. Okay. So there are many ways. So right, can we check other way like just nulls? Yeah, but there are a couple. Okay, is null probably? Let's see. Is null? Yep. So is null is not null. So they are both. I'm just assumed it should be there. So it seems like it is already there, operator. So just have to if not, just go back to the Google and find out something should be there. So So here you maybe see this syntax a little weird here, dollars, and this is other way to represent it. Other way I tried, why this one didn't work, column. It's still, yeah, it's still working. Okay, it still work. Okay, good. Okay, both way works. Okay, just want to make sure this also we can go with this syntax. The reason I did the alias here so that I get a column name. I want a column name. How otherwise? How do I compare? How do I do a filter here on the column, which is a result of the intermediate, or it's the intermediate result in our query, right? So I many times otherwise the result will be sum this, right? Instead of checking this, I created a name for that column using alias, and you can do another alias for this. I didn't do that because I am not checking the value for this. You can do that, right? As you see total units, I could have changed the value for the alias for this one as well. Alias, you create a column name you want. Okay, total amount maybe. One is units, other one is amount. Okay. So that way the heading will be good. You can see this heading doesn't look good because now the total amount looks better. If you are reporting purpose, this looks much better. All the stuff. Okay. So these things all you can do. As you see here. Okay. All right. So you can continue doing. So this is join, right? Okay. So now you see join. Along with join, we are doing group by alias. So this is just some few things I want to do in your lab, but that's good. You are knowing it now. Okay. Now again, you do it API way. If you get used to it, it is much easier. Until you get used to it, you can use the SQL way. Query directly from the table or create temporary table. Remember the temporary table concept? If it is coming from a file, you don't have an option to query it. What do you do? Suppose you are not comfortable with the API. It's coming from a database. It is not coming from a database. It's coming from file. Those two data frames, right? Your sales data frame and your store data frame. It's doing a count, is there, right? So other thing that we learned last week is you can create temporary tables, right? You can create temporary tables, and that will, how do we create temporary tables? Again, start with context, SQL context dot, I'm sorry, not SQL context, sales df dot register temp table. So this is the syntax, and name it whatever you want. We'll say store sales, sales tab. The reason I want to make it different from the Hive table name, otherwise it will, when you query it, it will confuse. Should I pull from the table or should I pull from here? Because it can pull, when the SQL query can pull from both. So that's the reason I changed the name of it. Okay. So I'm registering this table called sales table, and I also register the other one, store df as store tab. So two tables we registered. Once we register two tables, that's in your memory. Now you can run your query just like you used to do. Select store name. I'm just doing the complete units. Some, it's called sales amount, not sales amount. Yeah, sales amount EMT as total amount. Okay, from store tab, comma, sales tab. It's not case sensitive, I'm not worried. Where a dot store id equal to b dot store. It's just writing query, simple straight query, just like in SQL you write. Okay, group by store name. Store name is unique, so I'm not worried. Group by this, having okay, having total amount not equal to null. I don't know. Is not null. I don't know. Let's see. First do it without that, and I will see. Okay, definitely there is some error. So select store name. Let me okay, select store name, unit sum units as total units, sum sales amount as total amount from store tab A, comma sales tab B, where A dot store ID equal to B dot store ID. Group by store name. What's wrong? That's right, I think. Right? What's the error? Sum. You guys see an error here? SQL message take parameter does not take parameters. Oh, you know what? It's a simple error here. I have to say dot SQL. Okay, same thing. Well, the other two things didn't even come. And why? Because the join was, maybe it was a inner or outer or something. So it is good. So you can do this way as well. So look at the steps I have to do. I have to register the table, and then so that's another way you can do the join if it is coming from file, because then you cannot pull from the database, and you have to do this way. Register as table, then run the query. Simple, straightforward, using SQL context.sql. There are many ways. So there are various ways. Depends your project how they are doing it. Sometimes they will impose a standard. You do this way. So you need to know all the ways anyway. So it's easy either way. Okay. All right. So now we do this. Let's join. Let's look at the with column. Okay, it's another thing. With column is very popular. It's a very popular. You will be using a lot. For example, in our sales div, sales table, we have some columns, right? Units and sales amount and all that stuff. I want to I want to find the unit price for every transaction. Unit price. What do? I say amount, sales amount divided by units, right? Divide by. So divide by, hopefully divide will work. But anyway, okay. Before that, let me do the easier way rather than math thing. Let me look at the store. This math stuff sometimes create a problem. Okay, so this one, right? I want to create a new field called address, which will have city and state together. City comma state. Okay, so how do I do that? First of all, I want to create a new column, or new field, right? So that thing is called with column. With column will add a new column to the data frame. With column, what does it do? What does it do? I'm sorry. It adds a new column to the existing data frame. Existing data frame are 4 fields: store ID, store name, city, state. I want to add a new column. The new column will be address. Okay. And what's the definition of that address? It is concatenating these two fields, right? Which is concatenation of these two fields. Which two fields? City concat of this field and this field, and second field is state. Okay, so I'm saying with column, missed something, with column address, concatenate. Okay, this one, there is one more. Okay, so I'm saying, hey, I want to create a new field called address, which will be the concatenation of two fields. Of course, I need to put a comma in between so that they are distinct. And you know how to create a comma. Concatenation can take more than one fields, more than one arguments. Can be a field, can be a string literal. Here, these are fields, actual fields, city and state. You can create a comma here. Comma directly it will not take, but I'll show the error. It will not take because there is something called lit, string literal, that you need. So lit is another SQL function, like the import function. It's already there. I didn't have to import, but it gives error for whatever reason. You can have a import statement. Import arg.apache.spark.sql.functions, I believe, functions.lit. I believe that's the, something like that. S or S, sorry. It is S, okay. It is S. Okay. So you can so this is how you import a function if it is not available. So this is the import command. Import org.apache. Org.apache.spark is constant. You can remember slowly, right? Import org.apache.spark, then it's part of the SQL function, sql.function.lit. So there are many such columns. COL, there is concat, there is substring, right? These are all the functions I showed you last time. Substring, I think. So there are many of them, hundreds of them. Many of them are readily available. You don't have to import. But if it gives you error that, hey, I can't see what I don't know what you are saying, 90% of chance that you have not imported. Okay. In the actual program that you will write, your application, within the application, they will not be there. So you have to manually import. Because I'm directly in the command line, it's available. But when you write application, you have to make this import statement. Okay. So will lit act as a delimiter function? Yes. It's not a delimiter function. You can put anything. I said it's my name as well. It's basically a string literal. Lit stands for literal. String literal. Any string. Here I'm just putting here I'm making, I'm using it for a what do you call delimiter, but it's a string literal. You can put any string you want. Okay. Hard code with some string. Maybe I want to add US to it. Maybe I want to add US what do you call lit, the state name. I want to add that. Sorry, not state name. What is the country name? USA. Let's see. I missed another. lit, comma this. One more. Okay. This is the address. Phoenix, Arizona, USA. Right? It's a string letter. I want to add a completely fixed field. I can create a new field. Everything is USA, so I can put that there, right? So that's the address. So this with column is extremely useful because you are able to create new columns. And what do you do in at job anyway? At work, you will be creating new columns all the time. Because what is data transformation? Basically building new metrics, new columns, new values. And that's why you will be using with column. Okay. You can create multiple use column. I can do with column again. I can another new column. I can go ahead do 10 columns. I can add in the same statement if I want to, or you can do one step at a time. This one you can save it. First one you can say, okay, I will go ahead and save it. I can say then I can go ahead and keep on adding more and more. Maybe this is my store store address. This is my store address data frame. Okay. That you can store, and now store address data frame has a new column. You can look at it, always print schema. Now we have added a new thing called address. I want to add a new column. You can do again, right? With column. You keep on adding. So as you start building your transformations, you'll be building new columns, whether it's a string column, whether it's a calculated mathematical calculation. You can do all that stuff. And when it comes to assigning that value to a new column, you use with column. Okay. So this is the reason it is popular, because you 100% you will be using it. It's extremely common. So select, filter, join, with column, group by, uh, all the different SQL function, literal column, all those stuff. There are tons of others are there as well, but these are the most common ones you'll be doing. Um, and when it comes to saving this thing to a database, all you need to do is all you need to do is go ahead and write it wherever you want to write it. Totally up to you. Write it to a database, write it to a hive table, write it to a file, write as a JSON file, write as a Parquet file. We all studied that last week, right? So you have the full flexibility of writing any place, any format, anyway, right? So that's one. So with column and join, very common. Okay. Other thing now I'm going to do is, since we are talking about saving, let me go through the JSON thing. So now that we know with column how to use with column, I'll just put this thing in here so that you will see that. Example. Okay, this is how we can create with column. Now we'll go with. So these are the two additional APIs I wanted to cover, because it's common, very common, join and with column. And you already know select, you already know filter, you know aggregate, you know order by, which we did last week. Group by and aggregate. Group by or AGG go together. Aggregate doesn't go by itself. It always goes together. First you group by on the columns, then you do aggregate. Okay. Then and you know how to select few columns and more columns, right? With column, all that stuff. Okay. So now let's go look at JSON. How to read JSON file. Okay. So far we have looked at CSV file last week. We have looked at databases. We have looked at different formats reading. Now let's look at how to read a JSON file, which we kind of looked at last week very quickly, but let's do that as a proper exercise. We have the same file which we used for recipe. Remember from the Hive days, the recipe here is the two records from the ingredient or just recipe file. Two recipes, tacos and tomato soup. Ingredients are here, who is the inventor and all that stuff. I want to read it. You know how to do it in Hive, right? I have to create a Hive table. I have to use a SARDI. Remember, I have to import the JSON SARDI. Then create a table so that it will read this file, right? It was not that straightforward, but it's extremely straightforward in what do you call Spark. Okay, because Spark has a native connector, not even connector, native way to read JSON file and interpret it right away. So, for example, I will read a file. Say, okay, this is my recipe. Data frame. Anything you reads anything, it creates a data frame. So I start with the data frame. So when you're reading something, you say SQL context or Spark session. In our case, it's SQL context dot read. Okay. You can do different ways. You can do just JSON and give the path name. Straightforward. File and give the path on the data file name. Recipe.json. Straightforward. Just read the file. 2 lines, 1000 lines, doesn't matter. See how it reads. As soon as it reads, it automatically interprets the data structure behind the scene. You don't have to do that. In case of Hive, if you remember, we have to specify the data structure in the creatable statement. Here you don't have to. It will internally, the interpreter will automatically decide, look at the data structure and create it. This is a huge plus point. So if you have a complex JSON file, it will take a lot of time for you to create the Hive structure. But if you let the Hive, if you let the Spark read it, it will do it for you, right? For example, right now I can say, okay, dot print schema. It read the file and now it already knows the structure. For example, recipe is the string, which is the taco. Ingredients is a array, if you remember, right? Ingredient is an array. Here, name, there are three ingredients: beef, lettuce, and cheese. So it's an array. It automatically it found out it's an array. It determined. It did figure out that it is an array. Within the array there are structures, right? Within the array it's a basically structure, which the value of name of the structure is called, or name of the key in the structure is the name, NAME. That's why it's a name, which is a string. Then, so this is an array of structures, and the structure has one column called name. That's how you interpret. Second one is the inventor. Inventor is not an array; it is just the name and the age. That's all. So it is a structure. It's only a structure, not an array. So it's a structure. Structure has two values: name and age. So it is interpreted right away. So three fields: recipe, ingredient, and inventor, and the details about it. So I didn't have to do anything. It automatically did figure out the structure. So, and the value comes here. Ingredients are here, this. Okay. It comes as an array, as you see internally. Here is the inventor. That's a structure. Here is the recipe. Okay. One thing you notice, this is truncated. The value is very long. It may not show the whole value. How do I want to see the whole value? All you do is inside the show, say false. Default is true. If you change it to false, it will show the whole value. Just very small trick at work. You want to see the value, right? Before you want to do something. So you can just do that. Do a false. Okay. This is a reader file, JSON file, straightforward, nothing else. But many times you have to, after you read it, you probably need to do a lot of operation on top of it. That's something comes in, because you read the JSON, and the final output maybe have to be CSV file, right? Comma delimited, because if you have to read it, people who like the CSV file, delimited file, they don't want to look at JSON at the end, right? Suppose this is something you want to insert into a database as separate fields. This is where you need to probably create what you call, you need to do some operation. You can do that operation with column. Just to show you some example, I want to show the inventor age and name separately. Okay, and to add something called inventor age, name, a new column, and I want to add inventor age as a new column, because they are part of one column now. I want to separate it out. Okay, how do I have to add it right here. Inventory name is what? It is inventor.name. I haven't done this thing for a long time, so let's see. So we are creating a new column, client win name. The value is it inside? No. Yeah, okay, inventor. So I cannot do that. Oh, dot name. Okay. Dot name. I said comma. That's not comma. It's dot. So I added a new name. See, this comes as a separate one, right? And I can add one more with column. I want to see the age as well, which is inventory. See, I just putting short name. If you want to put inventor age, put that. That's something. It's up to you. And I'll take this thing and I'll say age. Right? Dot show. So I'm adding two new columns now. Oh, one I missed. So with column, okay, we added two new columns, right? And which is inventory. So these are separate columns rather than part of. It was part of one structure earlier. Very difficult to know. Look at it. If you are sending to another department, I want to separate it out. Okay, okay, that's one I want to do. And now you think, hey, there are these ingredients are separate. How do I separate those as well? Okay, okay, we need one more with column. Okay, and that will be ingredient maybe ing maybe in ingr. I don't want to have the same name ingr, and that will be just one, right? There is one called name, right? So it's a call. This command is called explode. How to explode a column, a array. To explode the array, we use something called explode. So you want to explode it. It's a column, and the name is called name. Is it name like this? Probably explode. So this is the end of explode call name, and here ends this maybe 2 or 3, I don't know. 2. What mistake I did? With column ingr, we are adding a new column. The value is explode of call name. Is it name or name? Small name. This. Let me see recipe. df.print schema. Case sensitive, by the way. So we have called, oh, it's called recipe. No, not recipe. It's called ingredient. Oh, ingredient is the array. Okay, ingredient, we have to expand the ingredients, not name. Okay, that's why. Okay. So this is not just name. We are expanding ingredient. Let's see. Ingredients. Okay. As you expand it, now it become, instead of 2 records, now there are separate records. You see that? But when you expand it, instead of this column being this value being a part of the column, for every value it gets separate records. Okay, it creates beef, for example, for taco. Now we have 3 values, right? So it creates 3 separate records: beef, lettuce, and cheese. Similarly, for tomato soup, instead of putting it in the same column or same row, it creates separate rows. That's how explode works. Okay, and That's how explode works. Then I want to select only the columns I need. Which columns do we need? I need the recipe. I need the inventor. I need not inventor. I need the INGR. I need the inventor name. I need the inventor age. Okay, I need only these ones. I don't want others because those will be repetitions. Okay, it's much more cleaner. Recipe, this is the ingredient, inventory and age. So it got rid of all the what you call arrays and structures. It's much more simpler format. Sometimes they need to see in this way. Not trying to see how to get rid of this thing. There is I think there is something I totally forgot. It's something. There is a way to so that I go to get rid of the square bracket. So that's something we don't need it. I know it's one of my colleague. He wrote some of these programs when I was doing this, so I don't exactly remember how he did it. So if I save it, want to save it to the database, save as table into the hype table, right? Let's see if it works. Adobe.trg dot recipe new. Let's put a new name. Let's see if it works. I don't know. It's warnings. So I'm saving it to the table. Let's go to the edit that table if I can get it. Select star from which table? I know it looks complex to you, but I will explain it. Okay, it has saved correctly because I'm able to pull it now. So what did I do? Here is a complex thing, right? Complex program. I mean complex in the sense what I'm doing here. I'm creating new columns because the original data frame has structures and arrays. I don't want to save it that way. I want to separate out those fields. And this is what you'll be doing at work a lot of time. They will tell you, okay, take this and put conditions, filters. You know, it will not be one line statement as you are doing here. I'm doing it in one line. You could do multiple, create data frames, then take it to the second step to create another data frame. So all these things I did it in one step with column, with column, with column. You could have done in 4 steps to make it simpler. Do first with column, create a data frame. Do the second one, do the second data frame, third data frame, fourth data frame. Right? You could do that. I just did it in one, but here we are creating one data frame, second data frame, sorry, third data frame. Not third data frame, third column. First column, second column, third column. Then we are selecting the columns we need it. Then we are saving it. Well, this is the power of Spark and Scala. You can change it. But yeah, you are doing tons of operation in one statement. If you have to do this in real other languages, it will take you 20 lines of code. That's the power. You can do a lot of stuff in single statement. Yes, you may not you will be able to do it right from the beginning. Once you get used to it, you can do it. Right. And then say, hey, can I filter out? Show me the ones which age is where the inventory age is between more than 25 or 24. Put a filter. There are many different conditions will come in your business logic. Show me the ones which where the inventory name is Alex. This, that, right? So those are all the things you'll be able to. Then give me the final file and send it to EDW. This is what we used to do in SalSwap. We used to get some JSON files. We have to process it, basically filter these that 10 different transformation, then create the file and send it to EDW. These are common things we used to do, and this is what you will be doing in many places as well. Okay, just copy this thing, but this is how you can perform operations directly on what you call JSON data format. JSON file for data format is little different because it has structures, arrays. And there are ways to do that. Structure, you say dot, inventor dot age, inventor dot name. If it's array, first you explode it. Once you explode it, data becomes separate. Once it's separated, and then you can do whatever you want. Then it could be nested. It could really get very nasty, to tell you the truth. But once you learn it, you'll just slowly get better and better. Suppose one array inside another array, you do two explodes within the array, then another structure with 2, 3, 4 values. So think about that. Explode, then within that one value, then say dot that value. So it could be very nested. So, but anyway, but at least you know how to start. Then slowly you'll get there. Anyway, I just pulled that data just to show you that it has worked, because we are able to pull it. I don't know how to get rid of this square thing. No, there's something long back, but not sure what was it doing. There's something. Get rid of square. There's something I told you. Bracket. In spark data frame. Those pandas. So I'll ask my colleague tomorrow. So start writing functions. This is how you start writing functions. Flattening. Select struct. Yeah, there is something called get item. Explode. This is what explode we're doing here. Maybe using sequence you can do that. I don't know which version is JSON to data frame. I don't know which version it is. Oh, this is just a function name. It's a function name, not the actual stuff. Okay. So this is how you read the JSON file and perform some operations. Beyond that, perform, you do more. There are tons of exercise you can do and just get better. What I say, with this knowledge, you can get to the job. In the meantime, you can practice tons of things on the web. Get some, just look at the transformation JSON. Other people just learn this thing, get to the job, or learn the rest at work. Right? You can't be expert and get to the job. You learn the basics, learn how to do it. Rest you learn in job. Yes, there will be struggle for 6 months. There is no what do you call alternative to that. But that's how we're giving you the first 20-30% of the thing. Rest you'll be learning at job when it. I can't teach you the every complexity, all right? Which in real project could have. But people do learn quickly, within 5-6 months. Okay. Other one, so that's the JSON. You can save it to file. You can save it back to any kind of archive or format, CSV format, however you want to do. Okay. So read it, then write it. You can write it to anything you want. Now let's go to DBMS. Okay. How to read from relational databases, and then you how to write to the relational database. In our case, we'll do MySQL, and chance of reading from relational database is very, very rare. Typically, by the time data comes to your Hadoop ecosystem, it is already a file or a hive. This is 90% of the use cases where you are not reading, or you'll be reading directly from hive table or file. There could be 10-15% of the cases where you'll be reading from the database. And just to tell you, in my office in CBS, currently we have a project going on. And this 2 days back, so they have done a Deloitte, you know the Deloitte, right? Deloitte team, we have hired them. Hired means they're coming into next 6 months. They're the 6-7 folks. They're they have to basically bring the data from Teradata and creating what you call some logics, putting it all together. Then they'll do Tableau reporting. So this is in this project. I asked them the other day. We had a meeting with them. They said, "How are you bringing the data?" They said, "We are creating a Spring. We are creating a Spark ingestion framework." I said, "Okay, so you are using JDBC and all that?" I said, "Yes." So many times, maybe because they are not using Scoop, they are not using all of those or any other tools. They said they'll use a Spark ingestion framework. If you are using a Spark ingestion framework to ingest data from relational databases, it has to be based on JDBC, which will show you. Basically, it will create a JDBC connection to the database with the credentials or all that. It can read the data directly from your source table and load it to the data frame. Then whatever you can do, right? You can save it to a file, save it to a database. So this is what the Deloitte team is building next few months, building the data, ingestion framework using Spark. Typically, this is not the norm. People use either Scoop, people either use FTP, all those stuff. But sometimes, as you hear, they are using Spark to ingest it, which is not common, right? Spark is for processing, but you can still use it for ingest because it has connectors. So just use that connector to bring the data as well. And they're creating a framework. I'll see in the next few months how are they creating a framework. We'll be working with them there, deciding whether they'll go with the Spark, Scala, or Python, because CBS is a Python sub. We are merging with Etna. Etna is also again Python. So, but they're thinking to do it in Scala. So there's some discussion going on with Etna folks to find out which way to go. Anyway, that's the kind of side discussion. So I just wanted to tell you. So how to ingest data from MySQL? In our case, in MySQL, it could be similar. Any other database, it's the same thing. Like only thing will change your JDBC driver. MySQL -u root -p Cloudera, and we have some tables here, right? Let's go inside retail DB. That's what we have been using for some time. And so tables, we have some tables, customer, all that stuff we did in our scoop exercise, right? So let's pull some tables from here. Okay, let me order or something, right? So how to pull the data from a relational database? Probably there will be some documentation here just to show you. Loading from relational database. Okay, right here. Okay, so here is it. So here is reading from the relational databases. In our case, it is MySQL, and here is the connect string. To connect to a database, any relational database, you need JDBC driver, right? And in our case, we have JDBC driver for MySQL. In any other driver you want to use, you can. Or any other database you have, you can use that JDBC driver. And this is a connect string. This is how you connect JDBC :MySQL. Localhost is our IP address. Our IP address is local. So if there is some other IP address, you provide that. And here's the port number 3306. That's the port number for MySQL. If something, some other port number they use, find that out from the DBA. Whoever is the right. So get the right port number, and here is the database. Okay. This is what we are connecting. And here there are many ways to do that. Here we are creating property object. Okay, we are setting the user ID and password. This is very common in Java world. Even in the Scala world also sometimes they do that, or they do that because Scala, Java, they are pretty common. There are a lot of commonalities there. So it's creating, what it is creating? It's creating a property object, and it's nothing but new java.util property. This is very common in Java. If you want to create a property file, property object, this is how you create. Then you can assign multiple properties. First one I'm saying user, set property. This is you can assign 100 properties. In our case, it's just 2, user, password. So that property object we can later on use in our connectivity. Let's go to the next step. Here, SQL context dot read dot JDBC. Say, hey, can you read? Now instead of JSON or CSV, we call it JDBC. What do we provide in the JDBC? Are the arguments to the JDBC operator or JDBC function? URL. That's where you are connecting. What's the table you are connecting? Name of the table and the property object. The property object just we created, which has user ID and password embedded inside it. Which has its JDBC, which has its thing embedded inside it. And when you do that, it reads the file, reads the table, and creates a data frame. Once it is a data frame, you can do anything you want, because we already know what to do with it, right? So let's do that here. So we'll create the JDBC string, connect string, we call it URL, and that's value is based on the database, it will be different. In our case, it is JDBC, MySQL, and okay, in our case, localhost. Otherwise, you have to provide the IP address, and port number is 3306, and database we are connecting is RetailDB, right? RetailDB. So this is our URL. We'll be connecting here is defined our URL. This is our connect string, where to connect, which database to connect. Next, we'll create something called property object, val prop. You can name anything. I'm saying prop. New java.util.property uppercase. Create a new property object. It's an empty property, there is nothing. Then you can start assigning. Dot set property. This is a one-time step. Property. Okay. And the thing is called user. User is what? Root. And password is let's set the password as well. These are standard names you have to put, user and password. Password is Cloudera. Now we have set everything. URL is set. Property object is set. This property has the both user and password. Now we'll connect. Let's say we'll bring in which table? We can bring in customers table. Let's see. Okay. So customer DF equal to SQL context dot read dot JDBC, and this takes 3 parameters. First one is URL. Second one is your table which you want to go or pull, customers. Third one is the property object which has all the user ID and password. You do that, this will connect to the database, read the file, read the table, and create a data frame. Your job is done basically. It will read the complete data structure from the table and gives you the table structure here. And you can do anything you want at this point. You can show it, you can query it, you can do anything, So directly pulls from the table. So you can query the table directly. That's a good point. Can I directly query the table using JDBC? I don't know. For example, I read the data frame, then query it, but can I do directly like SQL context? I'm not sure. No, it will not work because it is not native to. It is not native to Hadoop. Remember the Hadoop Hive case? It just used to do SQL, but it's easy because it's possible in Hadoop because Hive is native to Hadoop. It could just read it. But how do I read from JDBC? I read from database. That's something not possible because you have to provide the connect string, and for that I have to do all this stuff. Right, all this stuff. Then I will be able to show it or read it. How many records did it read? Let's see. 16,000 or 60,000 something. 12,400. So, and now we see the data frame, the print schema as well. I don't need all the fields. That's okay. I can say select which fields you want. I need only the customer name or first name and last name. And I need maybe city. I'm just giving example. I don't need all the three columns. I need only the students, only the ones which are only from some city. I want to filter out where this customer city equal to Dallas, or the city name it says. I don't know what city we have. I can do. Maybe there is Dallas. I have no idea. I'm so only the Dallas ones. Yes, we have. How many? Just count. Okay. Oh, 80 of them are Dallas. So see, so you pulled from the database, you did some operations here, like filter operation, selected only 3 columns. You know what? I got my data, I want to go ahead and save it back. Where do I want to save? I don't want to save it to Hadoop, MySQL. I will save it to Hive. And I will save it to this location. No, there is I don't think, there is no limitation. The number of the question is is there a limitation on how many records it can create in the database? You can keep billions as long as you have memory. There is no limit. In the real cluster, you can keep billions, but be careful how much on this. If you don't need the columns, don't pull it. Unnecessary taking up the space. Just be careful. Otherwise, you'll run out of memory pretty quickly. In my project, where data science project we were doing last year, we had three data scientists. We had a claim table which has 7 billion records, and there are 150 or I don't know how many columns. There are 500, 600 columns and 6 billion records. So we used to get out of memory very quickly when we have three data modelers or data science working same time. So you need to be careful what columns you are selecting. You need only 20. Just filter out pretty early in the step. Don't carry on the unnecessary waste amount of data all the way, and you consume the what you call hold up or hold the memory or don't do that. So these are some good practice. If you filter out the data, then your memory that you are saving or the data you are saving to the memory is much limited rather than saving every column which even don't need it. But there is no limit. Okay, so here saying saving save as table to Hadoop trg dot. Hey, I'm saving to a new table called customer. These are my Dallas customers. In one statement, I'm reading it and saving it. I'm filtering and saving it. So this is the power of it. Is, in single statement, I'm able to do 3-4 functions. Cannot remove the data to it. Just one thing you can do. You cannot remove the data from the data frame. You can do select, right? Dot select, then select the columns you need. Instead, there are 150 columns. Just select the ones you need. Create a new data frame, and it's a good point how to remove the data. Okay, that's a good point. Okay, I think I need to tell about that as well. Anyway, this one saves the data in customer Dallas table. Can I check if it's there? I'll come back to your question. Let's see. Let's start from this table we just saved, right? Let's see, it saved it to Hive table or not. Yes, it is there. Top 20. So I pulled the record from MySQL, chose only 3 columns, and then I chose only the ones which are from Dallas. So this is the kind of work you'll be doing. These are called data transformation. Filter, aggregate, all that stuff, right? I want to his question, his point, right? What do you call customer data frame, right? Dot print schema. So if you want to take out some columns from here, actually there is a, if that's their question, you can drop columns as well. I will drop these columns. I don't need it. I can remove those columns from the data frame. The email is gone. Okay, you can now drop many columns if you want to. Get rid of the password column. You know what? You cannot do more than one. Okay, there is another called drop all or drop multiple columns. Otherwise, I can do 2-step. I'm doing 2-step. There is something called drop all or drop something, drop columns, I believe. There is another function. So you can drop it. So that way your data frame doesn't have all the columns. You can drop it if you want. Just remember that drop. With column will add it, drop will drop it. The one you just created here, anyway, I can keep it in mind. Sure. You did this thing, right? Okay. I just want to keep it in your. Okay, this statement I'll keep it here. There is an easier way to doing that. There's kind of options and all that, but anyway, I don't know. I have to look for the syntax. Instead JDBC dot option dot the option. There is another way, like option, like the way we are looking at the CSV file. That's probably in. Well, yeah, here you can also do that. I don't remember what's the exactly statement. I think read dot. I mean, you can try. Let's see. Option URL, option user option. I believe. Anyway, okay. Look at your website. Look at the Google. So what I'm saying, instead of doing this, you can, instead of passing all 3 parameters, you can do option. Each option you can separately. You can specify. That is one way. Okay. Anyway, you are free to use this one. Not a problem. What I was trying to say. Okay, this one we did it. I'll just put it here. How do I save the data back to MySQL again? I got this thing and I got all the Dallas one. I can write it back. Same thing. Write JDBC and I'll give the URL and I'll create a new table called customer Dallas. I'm writing to MySQL, not Hive this time because it's by Hive. It's MySQL. I have to put JDBC and all that. And prop. This may need the this text double quotes. So we are taking the whole data frame and why am I doing this? Select. Where did I start from? Customers data frame. Oh yeah, that selects. I think that's fine. Okay, I selected only 4 columns. Filter only the Dallas. Write it back to a table in MySQL. Right. Write.jdbc URL, name of the table you want to create, and this is a prop contains your user ID and password. That should create the MySQL table. I should have mentioned the. Okay, that's fine. Let's go to the MySQL just to see. So tables. Did it create? Yes, right here. So let's start from 80 columns, 80 rows. These 3 columns we filtered out, only 3. 1, 2, 3, and only Dallas. See, you can read, you can write. You can read from relational database. You can write to relational database. You can read from one source, write to another source. Extremely flexible, right? 5, 6 data sources you can read from anywhere, write to anywhere. And in between you have Spark data frame, which you can perform anything. So that makes the Spark very popular in the industry. It's very easy to use, very easy to learn, and very less line of codes to build programs. You don't need to write hundreds of lines of code. That makes it popular. Okay, fast development and all that. Okay, so I we covered JDBC, JSON, Hive, Parquet ORC, CSV file, right? All different ways to consume. Other things are that XML and S3, Cassandra, HBase. You can anything you name it, it's there. Any database you name, there is a connector. Again, you cannot cover everything. So you can just look at the documentation, download anything you want to download. You can start connecting. So Spark is your universal platform for data processing in Hadoop world currently in the industry. I mean, that's the reason it's extremely hot technology. Spark engineer. It's very hot technology at this point. But today, one of my colleagues called, hey, do you know a good, strong Spark engineer we want to hire? There are some requirements. Do you know just anybody or strong? So, but anyway, there's some. Anyways, so because of its universal use, okay, and this is where you need to focus. More and more you practice these things, it's easier. Get good at one language, again as I said, either Python or Spark, Python or Scala. So that will cover some, who already has the language experience, that's great. You can pick up pretty quickly. Otherwise, you can pick up. But again, as you see here, you don't see a lot of language here. You can do 70% of work without learning too much of language, but you need at some point because you have to build applications. For that reason, language is extremely important. Okay. All right. So we'll stop here today. I didn't cover the UDF, so I'll not cover today. I'll cover Saturday. Saturday, what we'll do, first 1.5 hours, we'll do lab. Okay, I'll give those 3 files, sales, customer, sales and those 3 files, or I may ask you to pull data from the MySQL and perform operations on top of it. save it to different platforms. Save it to Hive, save it to relational database, save it to file, and in Spark you'll be performing operations. So so you'll be interacting with every system, relational database, Hive, uh, file system, and Purdue API based operations on Spark, API or SQL, either whichever you are comfortable with. So that's what you will do, because that's what the work you will be doing at work as well. Then after that we'll get into some UDF, and we'll get to Spark streaming as well. We'll do some introduction on Spark streaming. But this is the main topic you should be focusing on. Okay. All right. So that's all, guys. Any questions? Not that difficult. It's just practice. You are not really. This is not a difficult topic. If you have studied computer science or other languages, it's much easier. It's all about data. Pulling it, performing operations, very highly available, high level APIs readily available, right? With column, drop, join, filter. It's easy to learn. It's easy to learn. You just need some practice. Okay. But as you get good at one language, that brings up your profile many fold. That's where your confidence will come. And I'll always tell you, keep on studying one language on the side. Practice it on your own. Don't have to depend on me. Just start practicing. You have a full month or 2 months during this course. You could have become expert by now. You could have started, because language expertise you can build pretty slowly on the side. Tons of material on the web as well. So that by the time you are out of the training, you know the language and you know Spark and Hive. That's all you need. 3 things. You can jump to the market right away. Okay. Okay, guys. That's all for today. We'll meet on Saturday morning. Okay. And we'll do the lab and Spark streaming and UDF. There are a few things are left. I mean, it's a huge topic, but I think we'll cover a lot of stuff, and rest will be covered in the project as well. And we'll talk about the project as well on the Saturday, so that you can get started on the project. Next week we'll do the project during the weekdays. Okay, guys. So